This sort of follows on from, is in the context of the discussion that started around Aura's talk. I believe that if you look at this from a sort of property graph schema perspective, there's a distinct task, which is to actually, hang on, I just need to get rid of my, something that's in the way of my view of my slides. We need to sort of fill the gap, the capability gap between what you can do with very simple beginnings of schema in GQL or in SQL PGQ, and what you can do with the tools that are available in this space in the sort of semantic or RDF world. And people may have seen this post that I put up, which Aura referred to, on the desirability of aligning and looking carefully at how we take useful things from the RDF world and make sure that they're represented in the property graph world, and that we don't have superfluous fights when we could be creating parallelism or even convergence. So just a word of background about this LEX working group. This is an LDBC working group. It stands for LDBC Extended GQL Schema. The idea was basically schema equals types plus constraints, and GQL has a graph type that lets you define the kinds of nodes and the kinds of edges that you can have, but there aren't any constraints that are superimposed on that typing. And I mean, it's obviously a sort of semi-artificial distinction because, you know, a type is could be viewed as a constraint as well. But we start at the bottom with data types for properties, and then we build up records that can contain property types, and they can also have labels in a property graph model. And then we take those record types and we allocate them or assign them or map them to nodes and edges, and that we then end up with node types and edge types. So that's the sort of from the bottom up view from the type perspective, and we want to think about more complex relationships than simply the existence of a node type or an edge type. One example of that is not constraints as such, but understanding subtype relations, both between the content, those record types that I described, which are often referred to as content types, and the node types and the edge types that they're associated with. So currently one can deduce subtyping, but there is no constructive syntax in GQL to actually define, for example, the extension of an existing type with additional information. So we started, I said we restarted work in LDBC on property graph schema because there was a prior working group which was headed up by Jan Hidders, who's on the call and is active part of the LEX group. And the work that was carried out there, which went roughly, I think, from sort of, I guess, 2019, beginning of 2020, early 2020, you know, for a couple of years, resulted in the PG schema paper, which is an important record of some of the key ideas behind GQL graph types and some of the things that didn't make it into GQL graph types. So one of our jobs from a LEX perspective is to actually pursue or further some of the ideas in PG schema. I'll come back to some of the, what might be relevant there in terms of a future extended version of GQL schema. There are other sort of inputs. There are many design ideas from Neo4j contributions originally in the standards process to WG3, and many of them actually starting off with thinking about SQL PGQ and not thinking about GQL. So historically, we started working on the problem of how to define the target of a mapping from SQL tables or other tabular data to a graph. And the reason we were doing that was because we were working on a prototypical or experimental project called Cypher for Apache Spark. I think Stefan is on the line. Petra's in the room as well. So a number of us were involved in this project, and we tried to do 2 or 3 things with that project, one of which was to look at the problem of a compositional language for property graphs so that you could actually project results, which were graphs. And we also looked at this problem of mapping from underlying tabular data, and we had to do that because we were in the Apache world and basically in the Spark world, and basically in the Spark world, however, without all the possibilities, essentially you are likely to be dealing with data which is data frame data, which is therefore tabular data, and you've got to bring that data together to actually form a graph view. When Oscar talks about SQL PGQ, he'll describe that problem from literally the sort of SQL database view of that. I've got an SQL schema. How do I map that into a graph view? It's the same problem that we were looking at. But we thought, from a Neo4j perspective at that point, why not define the target, the graph schema, and then describe the mappings? Whereas in SQL PGQ, the schema is kind of implicit in the mappings, but it's doing the same kind of job. So there was we did a lot of thinking around this idea of graph schema and graph types and what it might involve. And again, not all of it got into the GQL standard. Then the other things that we talked about when we set up this Lex group were two different classes of input. One is existing standards that exist in other worlds for schema that's related to the problem. So two examples would be the RDF world, things like Shackle, for example, or the second example is from the JSON schema world, and indeed features that already exist in SQL. And the second class of input was data modeling approaches that are widespread. And we all know that if we take something like an ERM and we think about entity sets and relationship sets, and we think about the attributes that you could have on entities and attributes you could have on relationships, we're defining something that looks very, very similar to a property graph data model. And with essentially, I think the only real difference or exception is the ability to handle n-ary relationships, which is not present in the property graph model. So these were sort of background to what we were trying to do. I think now in this year, we have a sort of shift in focus. Everything that's happened around AI, graphs in AI and so forth has sort of pushed things around, upped the urgency, given people a different sort of perspective. And part of that different perspective is, but I've got ontologies in the RDF world. So what's your equivalent in the property graph world, which is an entirely fair challenge. And we've got graph types, no constraints. It's in its infancy. There aren't that many implementations. That's only just beginning. No doubt that will change. OpenCipher, which is still very predominant, doesn't have a schema capability. RDF, you could argue, or is sometimes heard to say there are too many schema standards, but they're much more powerful taken together, and they're widely implemented. So there is this gap, and there's the question about how do you actually address that gap. I think that we need to build up agreements on the property graph design and get it into property graph language standards, which is a process. But I also think we've been working on this for a long time, and that we ought to be able to actually do something to sort of nail this in the course of the coming year. A solution which has been toyed with is putting RDF schema capability on top of property graphs. And I don't think that that's going to fly. I think that that's actually a sort of a dead end. I won't dwell on that. It is also not a solution to just pursue our own approach and pay no attention to what's happened in the RDF world. And more interestingly, I think we have this question of conceptual modeling. Can we have a common front end at a certain level of abstraction where we're not interested yet in whether or not it's a property graph schema or it's an RDF graph that's going to, or it's going to map to a property graph schema and to property graph implementation at the data level or the instance level, or on the other hand, to the RDF equivalence. So I think we're interested in this issue of a sort of more abstract data modeling, and we're interested in the property graph schema version of this as well. I think that that means that there's maybe two standards or maybe three that need to be thought about. So is it possible to arrive at some kind of standardization of conceptual data modeling that doesn't scream RDF or LPG, but then has a defined relationship to existing technologies and to the RDF and property graph schema capabilities that exist or are being developed. And that defined relationship could be copy something or absorb something or evolve something that already exists. We need an extended version of graph types to include constraints. That's a shorthand for many, many things that could be included. And I think that we ought to look at the possibility of using a JSON schema dialect for describing properties. So I'll hand over to Dušan on that particular point. In fact, I think that would be, that's why not do this now? So just to sort of set the context, we've got labels, we've got property types. When we look at the property types, we imagine on the subject of constructed complex data types, that it's very possible that those are nested records of information. Nested records of information look like documents. We have existing tools for doing schema for documents. Those existing tools do many of the things that Shackle does in terms of things like value ranges, or string patterns and so forth. So there's a whole world of very fine-grained detail on property schema that we might be able to just copy JSON schema for. And in the Lex group, we did some interesting work to actually experiment with that. So Dušan, do you want to take 4 or 5 minutes to just run through that?
So what we've done here is considered two possibilities when it comes to JSON schema integration. One is to use JSON as a data type and simply declare that anything that exists in a graph and has and is of some data type can also be JSON. But also we consider the possibility that what lives in nodes as the attribution is actually only JSON. So we never came to the bottom of how we want it to be. But both possibilities are okay. You can imagine something being a number, 3 strings, a date, and JSON. Or you can imagine it being just JSON, which contains a number, 3 strings, a date, and maybe even some further JSON nested. So, well, without going into that sort of rabbit hole, deciding whether JSON is the only thing that exists and JSON is the only allowed thing that governs overall data types, let's see what happens if we try to integrate GQL data types with JSON schema. So over here, we've got a little repo that shows the mechanics of how that integration can look like. And we really try to see whether it's possible to run code with this, because otherwise it would have been a simple slide that says, and we are going to do JSON. But let's see mechanically how that looks like. Also, there is a complication around labels. So, which again, within the scope of the remaining 3 minutes, I won't go into, I'll just mention it. It's a solvable, it's a tractable problem, but it presented us with a little complication. So first we are going to declare that there is such a thing as a JSON, as a GQL meta schema. And we are going to then jump into GQL defs. This piece of work, as you can see, maybe right here on the top, has been done by Dominic, who I'm going to mention now and say thanks again. This was a lot of work done by Dominic, and then in the end we integrated it. You can see that this is a reasonably long document, and we defined, we ended up with the definition of a lot of GQL types for what they are and what they would look like as expressed in a JSON schema. So that's this document. It defines GQL number, and as you can see, GQL number is an interesting one. I wanted to bring this one into focus just quickly. You can see that it's either a number or a member of an enum, which is plus infinity minus infinity, or not a number. So we now suddenly start to have those things at our disposals, and then with that in place, with that whole mechanics in place, we can define a customer schema. We're building some example of something that everybody is building. So we've got a customer here. We've got properties, we've got some ID. That ID is going to be a string with maximum length of 6, first name, string, string. Then we're going to have a few things. Date of birth is GQL date. We're going to see how that plays. The customer can have some promotion, and we're going to say that that's expressed numerically, as quantified numerically as some sort of GQL number. But also I'm going to say here that there is a discount that we can apply on a customer level. So this customer is always going to have a discount between 0 and 100. I would like to be a customer who has a constant exclusive 100 discount on purchasing anything, and then the notion whether it customer is a VIP or not. So the rest is just mechanics of pure JSON. So this is what we expressed in that JSON, and then we can see how this all fits together. Here is a working example of a notebook. This one is written in Python. It's using some of the standard libraries. You just install those libraries and offer it the information that this is in this cell. That's now the focus. So we are going to load the information of the meta schema, information about the GQL definitions of the types. We are going to load the database, the dialect database type, whatever that thing was that I didn't show you. I've forgotten much about it. It doesn't matter. So we have the database type defined on that level. Okay, nice. And then we are going to load the customer schema. Fine. Then I can also uncomment this and then say load the customer instance to do something with it. That's fine. So let's run first cell. Let's run the second cell. And finally, this is what's going on. So we are going to now use the validator, offer it all of this metadata, and say now apply this, and create a little validation function. Say either validate and return true, or throw an exception, show us what's gone wrong. I'm going now to go and perhaps validate this string, or I could have validated the other JSON document that I loaded. So in this case, the thing that's on the screen is valid, but let's apply something like 120% discount, and boom, it says you are now failing the GQL int with the exclusive maximum and minimum of 100 and a 0. So this shows that the mechanics of this integration works pretty much out of the box. And with that, I conclude this demo.